In this video, we'll be learning how to balance chemical equations. If you haven't watched my intro video to chemical equations yet, I recommend watching that first. Starting off, what does it mean for an equation to be unbalanced? Essentially, an equation is unbalanced if the number of atoms for one or more elements is not the same on both the reactant and product sides of the equation, because this violates the law for the conservation of mass. Normally, when we write a chemical reaction, we start by just writing our product and reactants. For instance, if I want to write the chemical equation for the formation of water by combining oxygen and hydrogen gas, I would write hydrogen gas plus oxygen gas will react to form water liquid. However, what's something we notice about this equation? On the left side of it, we have 2 atoms of hydrogen. Let's just make a note of that here. And we have 2 atoms of oxygen. But on the right side of the equation, we have 2 hydrogen atoms, but only 1 oxygen atom. This is a really big problem because, again, it violates the law for the conservation of mass, which states that in a chemical reaction, atoms are neither created nor destroyed. So what we have written here is an unbalanced equation, and to make it accurate, we need to balance it. To do that, we can put leading coefficients before our products or reactants, because doing so will only change the amount of stuff we're using, but not the chemical identities of our substances. For instance, putting a 2 in front of this water means that we are now producing 2 molecules of water instead of 1 molecule of water if we hadn't had the coefficient there. It's super important you realize that we can only place coefficients because something you most definitely cannot do is place subscripts behind elements. H2O2 is hydrogen peroxide. It's not water. So when we're placing subscripts behind elements, we're changing the actual chemical identities of our substances. So the only thing we're allowed to place are these coefficients. But so let's take a look. We've placed a coefficient of 2 in front of our water, which means that instead of having 2 hydrogen atoms on the right side of the equation, we now have 2 times 2, 4 hydrogen atoms on the left side of the equation. The same for oxygen. Instead of having 1 oxygen atom, we have 2 times our implied 1, 2 oxygen atoms on the right side of the equation. So placing this coefficient of 2 has solved one of our problems. We now have an equal amount of oxygen atoms on each side of the equation, but you'll now notice on the left side we have 2 hydrogen atoms, but on the right side we have 4 hydrogen atoms. So how are we going to fix that? It's pretty simple. I'm just going to place a coefficient of 2 in front of my hydrogen, because if you take a look now, 2 times 2 will give us 4 hydrogen atoms, which means that that checks out as well. So the balanced equation for the formation of water is 2 moles of hydrogen gas plus 1 mole of oxygen gas will react to form 2 moles of liquid water. As you can probably tell by now, this process itself isn't that hard. You just need to make sure you're staying organized, and the way I like doing that is by having this little table down here where I just record all my different elements on each side of the equation. To practice, let's now balance this equation. Again, I'm just going to do my table down here where I write down all the different atoms I have present. And now I'm just going to count up. On the left side, I have 1 iron atom and I have 2 oxygen atoms. On the right side, I have 3 iron atoms and I have 4 oxygen atoms. So what's going to be the best way to do this? Educated guessing and checking. Something I notice here is that I have 2 times as many oxygen atoms on the right side of the equation as I do on the left. So if I want to double my amount of oxygen on the left, I'm just going to put a coefficient of 2 right here, because that'll change this 2 into a 4. And boom, those check out now. Something else I notice, I have 3 times as many iron atoms on the right side as I do on the left side. So how am I going to fix this? I'm going to put a coefficient of 3 in front of this iron, and that'll raise this to 3 atoms. Boom, that checks out as well now. Again, these questions aren't exactly hard. Just make sure you're staying organized. To finish off this video, let's balance the following equation. Sodium hydroxide and potassium nitrate combine to form sodium nitrate and potassium hydroxide. Even though this equation is a lot longer and a lot more complex than all the other ones, all of our steps are still going to be the same. I'm just going to start by drawing my table, and now I just count everything up. Something you really need to make sure you're paying attention to in these longer equations, although I have 1 oxygen in my sodium hydroxide, I have 3 oxygen atoms in my potassium nitrate. So these are going to have to add together for 4 total oxygens on the left side of the equation. Just make sure you're really keeping that in mind. You'll see that it's the same for the right side of the equation. I have 3 oxygens here, but 1 oxygen here. I'm going to have to add those up to get 4 oxygen atoms total. And so with all that counted up and my table filled out, I'll see my sodiums check out, my oxygens check out, hydrogen, potassium, nitrogen, all of them check out. This equation is already balanced. It's the way it should be. So as I hope I've shown, even with the really big ones, you don't have to be intimidated. Again, the process is easy. Just draw the table, make sure you're organized, and don't make any stupid mistakes. And with that being said, that's all you have to know for balancing chemical equations in chemistry. If any of this was confusing, I recommend rewatching parts of the video. If it's still not making sense, take a break and come back after. Thank you for watching.